Okay, let's go ahead and go live. All right, hello everyone. Welcome to another design review, part of the 14.2 cycle. And what we have right now is mathematical computation. So, I don't quite know why it's under algebra, but game theory is one
Right.
big area we're going to be talking about. Array algebra, GPU arrays. We already talked about a bit
Yeah,
in a
we've
different
covered that
design review.
in a different meeting.
Okay, equation solving. Okay. Integral transforms, discrete calculus, symbolic array variables. Okay. Oh my God, it's starting to seem like a university with plans out to 2027.
Yes.
Well, it is Wolfram U, you know.
I know. And we're going to be really pretty serious. We're getting pretty serious here. We've got a pretty serious set of course offerings, which is great. All right. We want to dig into game theory.
Yeah.
This is going to be a slightly heavy lift, I think.
Yeah. I mean, if you want something easier, you could start with array simplification and stuff.
Let's start with array simplification, and then okay, is there a guide page I can start from, or am I looking?
Yeah, actually, you could go to.
Let me start with this. Let me just start with just looking at some examples.
Okay.
So here's a question. People have been bugging me for years about non-commutative multiply and doing the same kinds of operations there. My question is, what has to be done there is very similar. Should we have a single function that does both of those kinds of things, or is array expansion very separate from non-commutative expansion?
I think
the non-commutative is its own. It's very abstract.
Yes.
You don't know what it is.
exactly. That's much more general, right? And all of these
Right,
operations, even though they're not non-commutative, right? They're anti-Hermitian, or we have some sort of structure
fine.
there.
Yes. And 14.3 with any, and the next one with any luck will have non-commutative algebra as a generalization of this stuff. So Adam and I are already working on that.
Okay. Do we have any sense of what? I mean, that's going to be things like expand and factor and so on for.
Also Gribner basis.
Yeah, I understand.
Yeah,
but I'm more interested in the basic stuff.
Yes.
Yeah, we need to work through the basic stuff.
Okay, but I just want to know design-wise, what
Mhm.
we imagine is that we will have a non-commutative expression, but we will be using ordinary operations like expand and factor on that different structured expression, rather than having our own custom operations to work with non-commutative things. Is that correct?
I think so. We haven't really thought about it yet.
Fine.
Yes,
All
we're
right.
working.
That would be my guess at this point.
Yeah.
Okay. So I see. So here you're declaring those as scalars.
Yeah.
And so they're being pulled out. That's pretty amusing.
If you go to that page, you'll have lots and lots of examples.
Array expand.
Yeah.
Okay. Well, I just want to get a sense of what's here.
Sure.
And then I want to understand the difference between simplify and array simplify.
Yep.
Is Adam here, by the way?
Yes, I'm here.
Oh, okay, good. Okay, what does scalar expand do?
Basically, represents the expression in terms of scalar variables.
So many functions don't have array methods, but they need to operate on scalar stuff.
What is that thing there?
Indexed.
And why does it have the parens in the display? Seems like a bug.
It's a design issue with precedences. I don't think it's worth going into the details right now.
But can it be fixed?
I don't think so. Not in general. right? It's indexed of a thing, right? And the thing inside is not sort of, you know, right? It's like if you had an a superscript of something and then you underscripted that whole thing, right? It'll put parentheses around that.
Yeah, but look, the thing here doesn't need parens, because just like if I have a single look, in this case here, right? I never put parens around x because x is already an atomic thing.
Right, but if you had x super 2 and then you put a subscript on it.
Okay, here's what I claim. Okay, I think that it is just a choice that this vector symbol thing is treated as a composite thing that needs to be parenthesized so it doesn't fall apart when you start biting it with subscripts. But in fact, it is an atomic thing. You see what I'm saying? The notation is sufficiently unambiguous that we don't need to put the parens.
Yes, but the parens aren't coming from the head; they're coming from the box structure.
I understand. I understand.
So
But that's a
it's
Jean-Paul's question. Why did you ask him?
okay.
Okay. I really think we should try to avoid it. I really think this is a kind of an important thing. I think having these extra parens is pretty yucky. Okay. So, okay.
I disagree, because how do you tell the difference then between part 2 of a vector named v and a vector named v2?
Well, that's a fair point, but I don't know. I mean, I don't like them. I mean, nobody uses this. Look, in that, if that's
I disagree with that statement.
Roger,
Right.
what do you have to say about this?
I'm kind of with you, Stephen, that
what people do, the reason people don't normally use them is that they'll remove the vector, right? And they'll just write v2, right? They'll have separate notations for the scalar and the vector object. But here we only have the vector object and we're taking part 2 of it.
Yeah, I think your argument about the fact that you can't distinguish it from v sub 2 as a named vector is completely specious, and here's why. Here's why. Look at that over bar, right? If it's v sub 2, that over bar will extend longer. It is already a bracketing construct. See what I'm saying?
Possibly, yes.
So there won't be a confusion. Well,
right. Well, that's fine for vectors, but what about arrays?
Well, right? They've got this double overbar thing. It'll do the same thing.
No, matrices have a double overbar. Do array symbol of v comma 3.
Okay, it's a case where it doesn't where it won't work, right? But I mean, I'm. What's that doing? What's that?
Well, you didn't give it any demand. I mean, it needs to, I don't know, give it some. Yeah.
That's really obvious that that's not, in other words, if I have another subscript here, it's going to be very obviously different, I think. Well, in any case, I think that's a corner case. Let's just find out whether it is technically possible to strip those parens in the, given the boxified rendering, and do let me know the answer. Okay. My next complaint here is about this name scalar expand, because I would expect, I mean, what it is doing it is like a bit like function expand or something. It is writing it in terms of scalars. It is it's really componentizing it, isn't it? Why isn't it called component expand?
Well, I guess. I mean, yeah. I mean, I'm thinking components can be any dimension, but
Well, maybe they
But
can be, but I mean but look, scalar expand is very confusing
okay.
because it's not expanding the scalars. Array expand is expanding the arrays,
Yes.
whereas this is componentifying everything.
Right. Or that right. This is more like two scalars or two components.
Yes, I agree. But I think two components is a bit too general.
Yeah.
And I mean the fact that
And,
we're calling
and
things,
also, it's a very serious expansion. If you have something with high dimension here, it's seriously going to expand a lot.
no, I know. The other thing that's in here is the indexed concept.
Mhm.
But I think we're still calling it components. I mean, it's what everybody would always call it. I want to see the components of the vector.
Yeah, it's fine,
Yeah.
Stephen. If you want
But
to say
what should it specifically be called?
component expand, doesn't sound bad to me. Sort of in the
As
expand
opposed
family.
to components, for example. I don't know whether we want to use such a general name.
It seems very general.
Yeah.
I mean, this is a useful function, but I don't think it's that useful. I mean, it's like,
Fair enough. But the problem that I have with component expand is, I mean, it's better than scalar expand.
Componentify?
Yeah, but something like that. But I mean, it's what other words are there than like expand? Like we have, function expand and things like that. But what other things, we have normal, our famous, whatever. But what other things do we have that are doing things like this? That are
Component
breaking
expression.
something? What's that?
Component expression. I mean, it's really
What does that mean?
expression.
Oh no, you're saying what?
I'm
I don't
saying,
think that's
sorry,
good.
I'm
no,
saying,
but
Anytime you use the word expression, it's a no-op.
yeah.
It's just adding
But I mean,
fluff.
but that's what it really is doing. It's giving you an expression which is equivalent
well,
to
it's a
the
type
earlier
of
one.
translation.
Yeah, it's like a translation, maybe. Yeah, something of that sort. It's
No, but where else do we have something where you go from a single symbolic thing and you are sort of, I mean, it is in a sense expanding it out.
Yeah.
We've got function expand. What else do we have that's kind of like that? I mean, function expand, component expand would go with function expand.
Sure.
Trig expand, complex expand. Now, how does this relate to complex expand? I guess it really relates. It's really the same
Yes.
kind of idea.
Right.
All right. I guess I'm good with, I mean, all right, I guess I'm good with component expand. Well, that's
right. Now we got we got array simplify now because it was kind of last minute thing, but I think array simplify is much better for documentation and to make sure it's in the. So I'm sorry, but
I don't
everything
understand
else.
what you're saying. I
So
mean,
I'm saying that,
simplify
yeah.
should work on these expressions, right?
It does.
Yeah, so the point over here is that simplify does work, but it also makes sense to have an array simplify because simplify is a huge machine and even worse, full simplify. So what you really want is for people to have a kind of guarantee that when they work with arrays,
No, I
they
got
get-
it. It's the thing
So if
that
you go to-
specifically deals with the arrays,
yeah,
just like function
and-
expand specifically deals with things with functions, even though simplify might do the same transformation.
exactly. Now, array simplify has got a beautiful reference page, which is certainly worth looking at when you have time because it's got some really deep expand, a matrix
Array
simplification.
simplify, you said.
Yes,
Yes.
that's the one that you want to look at. It's a beautiful page. It came up like very recently, so sorry. Yeah, that's the one to really look at. It's quite beautiful, I think.
I think, by the way, multilinearity shouldn't be hyphenated.
QA will take care of that once it's defuturized.
Yeah.
So we've collected lots of matrix identities, and that's the matrix section over there, and the scope is beautiful.
Okay.
I'm just saying because we spent so much time on it. Okay, I have to say that. Sorry.
How does it know that A is I mean, this thing here, if I just type that,
So it makes assumption for things like
I see.
inverse, right? It makes assumptions that that A is of a type that for which it will make sense unless you provide some assumption which contradicts that.
This is really nice. I agree. This is really nice. Does matrix log of matrix power do something useful? Do you understand what I asked? Does
Adam?
matrix log a
No,
matrix power?
No.
not that I know of.
But you can, in principle, do that, right?
Yeah.
I mean, what's
Yes.
that?
I mean,
Okay.
yeah, it's a matrix, so it's no
Yeah,
problem.
so it's matrix log of matrix X. Should go back to the original thing again.
Yes.
Just pointing it out.
Yeah.
Well, this is a lot of relations here. This is going to be very useful to people.
Yes.
And you haven't even gotten to the examples with symmetry yet.
Mr. Symmetry.
Okay, element. By the way, surely we should make it be the case, and maybe it already is the case, that if you just say array simplify blah, 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 comma, matrices mn, that it should assume that all symbols are of that type. That's what we did with some solve stuff and so on, right? Where you just say reals.
Right.
Right. You remember what I...
In a complicated expression case, it may make no sense or be difficult to figure out what exactly is supposed to be a
Then
matrix.
make an error, then give an error message. Right? But the general
Right.
case, when I say, solve, x squared equals 6x plus 10, x comma integers, it just works, right? I don't have to say x element of integers. See what I'm saying?
In fact, that means something different if you say X element integers in the solve case.
Right. So solve is different in a sense that it has to figure out what the variables are no matter what. Well, simplify doesn't try to figure out what the variables are, and now it will have to figure out what are variables in the general expression.
Well, I still think it's a useful thing to do because in this case here, it's very clunky to have to write this. It's just like everything's an n by n matrix.
Right.
Now simplify this.
We do not have simplify something comma reals, and it might have problems if we try to implement something like that.
Why don't you think about it?
Yeah, I'll think about it, but yeah,
I mean, it might not work.
I'll see if I can, either implement it or find problems that are sort of
Fine.
make it
Okay.
really hard.
Where's the symmetry stuff?
Actually, the only symmetry example that I have is in full simplify.
Oh, okay. I didn't realize that.
Okay. Well, let me look at what that looks like. Where? Oops.
Oh, you need to look at source.
Yeah. That's fancy. But now, would this work also with array simplify?
Yes.
So I
That's
can
the
put
point
this
that it absorbs both simplify and full simplify. I mean, I do have one example where it didn't, but it should. That's the whole point.
Well, it didn't work.
Or didn't.
Are you in the prototype build?
Yeah.
Oh, interesting. Huh. And they're not colored, the symbols. This was working.
I I did add it recent. So there was something that broke it recently, and I fixed it recently, but
Okay, all right,
maybe
fine.
too
Yeah,
recently.
All right, all right,
We
all
got
right, okay,
a build failure.
okay, all right. So, I mean, what else should I look at? This looks really nice. I mean, let's look at scalar expand or component expand now. Just so I understand, things like matrix X, matrix log, all those kinds of things. I mean, if I look at like singular values, let's say, that's hopeless for this symbolic purpose, or is that not true? Is that true or is that not true?
I think that's basically hopeless.
Yeah.
Yeah.
What about the neural net operations? What about layers and things?
I mean,
Most
those
of those are
those
nonlinear, right? So
no. Most of the most of them are just basically kind of like dot products and stuff.
Well, they're dot products with activation functions, so that may or may
Yeah,
not work.
but yeah, I mean, yeah, ignore you can't, anything with the activation function is going to be not.
Those parens are just not okay. Again, show that to John, this case here, because at least that we could fix by changing the way that I forget what it's called. Oh gosh, what the heck is it called? The way that these operators grow. There's a way
yeah.
there's a specification for that symmetry or not.
No, there isn't. I've discussed this with John. If you want to have a separate discussion about this, but John
Okay,
has
fine.
very grave concerns about changing this behavior. So
Okay, but then if we got rid of the parens, we wouldn't have to have an issue with the behavior.
okay.
So these things are indexed list M21, correct?
Yes.
Okay. Again, I just want to review for a second. What kinds of functions are, in scope for this type of thing? I mean, I'm sure you've gone through this, but I mean, so like cross product, presumably yes.
Yeah.
Yes.
All these things like projection, presumably yes.
No.
Why not?
Well, or at
Okay,
least
I'm going to go and poke at more of these. Okay, I don't know whether projection can be done
Here's a
on this.
couple of surprise ones, which is descriptive statistics like mean.
Yes. Okay, but I'm just trying to understand from here.
Yeah.
I bet there are symbolic things that can be done with circle points, for example. Just saying. For sure, a constant array, presumably you've done that. Constant array with the n.
actually, we have the symbolic ones array instead of constant array, because the constant array is something that doesn't really like symbolic input and
Okay,
wants
so
to
can I make a
construct stuff.
suggestion then, just in terms of connectivity? Can you change the error messages of constant array so it mentions ones array?
Okay.
And also make sure constant array points to ones array in the C alsos. But more importantly, give the error message. Make sense?
Yeah.
Okay, so here, now div and curl and so on, those you have covered, yes? You've covered div and curl, right?
For simplifying div and curl, no.
For
Div and
componentizing.
curl work with array input, or at least div works. I don't know about curl.
Okay. Why doesn't simplifying work? I mean, it's not obvious to me what it would do, but you've dealt with
So
like,
the short answer is I haven't looked at possible simplifications there.
Fine. I'm just poking at, go through these pages and make sure you know what's possible, right?
Right.
And here, similarly, like I have no idea whether like singular value decomposition has a hope. I have to believe some of these do have things you could do with them.
Well, I mean, linear solve, we should definitely be able to simplify.
Yeah. Yeah, and I mean, some of these things, you know, matrix rank, presumably, well, I mean, that depends on the content of the matrix, so it might not be able to be simplified much, but it might be, there may be trivial cases in which it can absolutely be simplified, where there's a zeros array and things.
Right, and again, I think matrix rank may complain about symbolic stuff.
Okay, but then
Which
maybe
we
we
might
should
just
fix that.
disable it, the complaint.
Disable the complaint, yeah. I think now we can disable the complaint. The complaint made sense when there was absolutely nothing we could do with it. Still not tries. That might have something you can do. Anyway, you guys can go through this, right? I'm just saying you should go through everything.
Yes, we should just go to system.
Like for example, I'll give you an example of something we can definitely do. If you say eigenvalues of a matrix, the length of the eigenvalues of a n by n is just n, right? So that we know, independent of what's in the matrix.
Depending on how you count, right?
count multiple. I think we always
But I
count
think the way we count them, we include
Yes.
degenerate
Yes.
eigenvalues.
definitely.
I think
Right.
length is another one of those that.
Or symbolic length definitely cannot be used.
Yeah, symbolic
We-
length we don't really have, but that's the thing we should
Yes,
be
like
thinking
tensor-
about potentially.
Tensor dimensions might be able to handle it if we teach it. Like
Right. Anyway, I'm just saying, just, you know, go search for more things which we can do. This looks wonderful. What else should I look at with respect to this particular area? And then we're warmed up and we're going to get into game theory.
Yeah, I think that this is it.
I'm very impressed. It's lovely and people will really like it.
Do we want to look at scalar symbol?
What's that?
Oh,
Oh, we didn't put it over here? Oh, sorry, it didn't go in.
I think
What
we
is
forgot.
that? What is that? That sounds very
Again,
suspicious.
It's
Adam?
again even more
So I
recent
found something like
innovation.
so it's for completeness. There is no way to specify that something is a scalar.
The only
inside-
way right
inside
now
the
is an
something without
array with an
assumptions. You
empty
have to do
dimension
assumptions.
list. You can use an array with
Fine.
an empty dimension list.
So since this is something I
Boy.
implemented
I mean, this
yesterday,
is
doesn't
unfortunately
have
yet another example of a formal object. Because scalar symbol can't have a value, right? You can't say
Right.
scalar symbol of S equals 17, can you?
No.
Right. So like a formal object,
right, but it's
Right,
like
right, but
array symbol, vector symbol, and so it sort of goes into this category.
no, I agree, but I'm telling you, we should have a thing called formal symbol or something, which could be typeset with a dot, and it has to have some way of being maybe entered even with the expression with a dot. Maybe the expression with a dot should be equivalent to something. I don't know exactly how it should work, but
right,
did
but
we had-
but formal symbols have no right. They're purely formal, or at least the part of the point is that they can
Yeah.
be purely formal. Whereas this has definite properties, like a domain.
I get it.
That said,
I get it. I get it. But I would like to raise the question again, not for this meeting, but for an LCC meeting, that having a function like formal of quotes A, which turns that into A dot. I've just needed that so many times. Formal, informal, etc. See what I'm saying?
Yep, I can pass this along. Yep.
That sounds kind of crazy to me, as I've said
I-
before.
I
So,
understand, but I know I've needed that so many times. It just drives me crazy.
well, I'm not convinced. To quote Stephen Wolfram, I'm not convinced.
Fine. I don't disagree with you. I'm not fully convinced either. But it's another form of activate inactivate. It's a way of doing that in a way that we haven't really thought about before, of just changing the symbols, so to speak.
Sure.
Oh, I noticed Sander commenting that also complaining about the scalar expand and saying it should be expand scalar based on the. But anyway, component expand makes a lot more sense. Okay, let's dive into game theory. All right, where do I start?
There's a guide page, which is, if you bring that up, you can use that to navigate to all these source pages. Yeah, use that. No, oh,
What should I be using?
that other symbol to the right, because then it will, will help you search. So type in game theory. See? Isn't that nice?
Along with game pads.
Yes. Works nicely.
All right. Let me see if I understand anything about any of this. All right. Should I start off by looking at a few general examples here? Does that make sense?
Yes,
Let me just
yes,
look at
yes.
an
You,
example.
you could. I mean, yeah, if you had not a lot of success, builds of things might sometime not work, but hopefully, yeah. But that's
No,
the
I'm not
simplicity.
running it. I'm just looking at the example.
Yeah, sure. So yes, you can. That's the simplest example. 2-player zero-sum game.
What the heck does that mean?
Go to matrix. It's the payoff.
No, I know what the
Matrices.
payoff matrix is, but what's this iconography mean?
That means that you can see the payoff at a glance.
But maybe Mark can just say what do these icons mean? I don't understand. What does this
It's a
mean?
bar
This means-
chart.
It's a bar chart representing the payoffs of each player.
I
So
see,
the
I
player
see.
on blue has a payoff that's blue. The player orange has payoff orange.
Yeah, I get it. I get it.
Yeah.
I think this could be made better. I like the concept. I think it can be made better. I mean, I think from a graphic design point of view, now if I have 3 players, I don't
Yes.
understand how
Well,
this
go to the page then.
matrix game plot.
Mm-hmm. Go to the F, yeah, and then click that dot. These are prototypes. Those are not final illustrations.
If it's possible to see if Jeremy could join us here for a minute.
Yep, I can check. Yep.
And so here you can see it's basically a type of flattening operation.
Yeah, I get it.
Okay.
My question is this type of chart
Mhm.
is more general than, it shows up in matrix games, right? But it's actually a more general kind of thing.
Yeah, but we invented it. I invented it. So
Fine. But maybe
so
we
if you
should
scroll
have
down, there is another one. There's another way to show it. It's called a split square. If you scroll down.
Yeah, okay, but fine. But hold on. I'm just thinking about the following points.
Mhm.
This, where is split square? Where is it?
There.
There. That's much more obscure.
Yeah. It's that one is standardly used in some of the literature. We generalized it to n-player games, which I've never seen before.
Right. Okay. So I understand that this is an attempt to take a rank n tensor for n players and to
Rank
render
n+1.
Okay. I thought this is a rank 2. For 2 players, it's a 2x2 matrix, right?
The values are vectors. Okay, it's kind of like an image. You have a color array. You have RGB at the
Right,
component.
but the rows and columns, the thing would naturally be a 2x2x2 for an n-player game. No, I'm sorry, it's not for an n-player game. It's an n by n by n times
No, go
hypercubic
to
object.
go to matrix game, and it's described there. If you open the ref page for it, but I mean it's just about right. Okay, it's just that details not quite right.
Okay.
That should be Okay, that's prototype. Don't worry too much about it. So
Yeah, I get it. Each one has a payoff. Each player has. Well, now I'm confused by this.
Okay, go just below that data set there.
Mm-hmm.
Look at that sentence. Okay. So
a P of payoff.
Oh, there's something wrong with it. There's a payoff array. Oh, an array P. Oh, where we define P of payoff vectors. So it's an n-dimensional array of vectors. Okay. So if you look at the dimension that comes a little bit later in that sentence, M1 through Mn, those are the, like player 1 has M1 actions, player n has Mn actions.
Right. Those are the actions. Yeah. So
those are the actions. And then you need a vector at the end that says, like, how much
so what you're doing here is those two things. This is player 1. This is player 1's action 1 and action 2. Correct?
Yes.
I see. Okay, fine. I confused.
So there's sort of labeled versions of that too. And
are we going to be able to find Jeremy?
I was not able to reach out to him yet.
Could you ask Kristen, please?
Yep.
I mean, let me start commenting. Should I start commenting on this? I can start commenting on what I think. I think this is close, but I think it can be better.
Sure.
Okay.
And the reason to have that plot function, I think it's a nice way to communicate.
Oh, it's great. It's great. I have no problem with it. I'm just thinking about how to make it better.
Okay. That plot function also have a highlight function.
Yes.
So there's a second argument.
So a particular move, you can highlight a particular move. Is that correct?
Actually, the thing we highlight now is a strategy. And that could be just a move, by the way. That's a pure strategy, is a move. Okay.
How do you highlight a strategy? What does it mean to have doesn't a strategy have to have weights and things?
Yeah, so a mixed strategy can have weights. So go down. I think it's in the matrix game plot. Matrix game plot. You can either look at the notes up above, or I don't exactly know what the examples are for that, but maybe Mark, you could tell.
Yeah, I mean, you could search in the option examples.
No, search what?
Options, and then you should have game strategies.
Okay.
Although, that's technically
no,
not
that
true.
Became an
That's
argument.
not true. Yeah, that became an argument. Sorry, that's old.
Yeah, that's old. Go up to the notes, the details then.
Yeah. By the way, anytime you span like this, you are going to confuse people.
Yes. Yeah, we don't do that anymore.
We don't do that anymore.
It should have plot range padding.
Yes.
Yeah.
That, and it also has a center line, so you know what's positive and negative.
I was going to tell you exactly the same thing.
Okay. Well, we know. We're still iterating somewhat. Okay. So that's there. It's just it hasn't been reevaluated here. And by the way, that option is gone. So.
Yeah. Make another suggestion. Okay. By the time you've got those center lines and you've got these lines here aren't right. Maybe those lines could be dotted lines. That might look better. See what I'm saying? Because those lines have to not get confused with the the framework lines here. You get what I'm saying?
Mm-hmm.
Maybe just gray would be okay.
Yeah, I think graying them out a little bit would be, they shouldn't dominate. I agree.
Right. But in a sense, what you're doing here.
One way to show the strategy is, so like if you take the orange, the row player here, there are 4 possible actions. If you have a strategy, that will give you a probability to do each one, right? It's a number between 0 and 1. So we could visually indicate that with thicknesses.
I agree. On each of those lines there.
On each of those lines there.
Okay, so I've got a suggestion.
And we can put labels on them.
Guys, I've got a suggestion. First of all, I suggest instead of making that a dot, that you make that whole bar there yellow. So then what you'll see here is a green bar at the top and then blue bars here. what I'm saying? Because it isn't really a dot. What it's really saying is all these things are possible, moves for
But will
yellow.
that be how visual will that be?
It'll be fine. It'll be fine. You just have to have the thickness of that bar be right.
Yeah, we'll see.
And then what you want to do, then what you should do, I think, then the sum of those has to be 1, right?
Mm-hmm.
It may work to just take, I mean, obviously you've got to have a case for 0, so there's got to be a dotted line or something for 0. See what I'm saying?
Right.
And then you can have different thicknesses of gray, I would think, there to indicate the intensity, so to speak.
Mm-hmm.
And what I would do is I would span, I would have the yellow bar span almost all the way to the edges, right? So that these things come down. So rather than, I think they'll be less obscure. And up here, you don't have them quite join in the middle, but you have them slightly pulled back from the edges, but you have a blue bar there and a green bar that goes across the whole thing. I think. That's my suggestion. Make sense?
Yeah, I mean, it's worth trying. I mean, these things one kind of has to try, right?
I know. As you're well aware, I've spent my whole damn life.
I know.
These things. So I'm not completely clueless. I might be wrong, but I'm not completely clueless in this domain.
Yeah.
Sanders says disk is greater than bar. He likes the disk rather than a bar. Well, he might be right. We'll have to see. I mean, it could also be that you could have a disk in the middle there, and you could have, I don't know. I just think you don't want another black line here. It's just obscure. Anyway, okay.
There is one argument to keep the disks, which is that disks often represent, like in the other notation we'll have in the tree game, eventually we do use that kind of same idea.
Fine. All right. Okay. Well, maybe so. In which case, maybe it's enough to just have some kind of gray or dotted line here, right, as a spanning thing. Do you see what I'm saying?
Yeah.
Do you understand what I'm saying?
Yeah. Yeah.
If you don't, I mean, I can just go into the code and start modifying these.
No, Mark is being changed every day with Rogers, so I think he very well knows. Yes.
Yeah.
Okay.
And we have Jeremy now.
Okay.
Hello.
Hi there. We're trying to make this iconography. But let's if we're going to move on to a couple of other things. So if you can, we'll come back to this. Okay, this is iconography for representing games. Okay. And also, I'm not at all sure that we should use the same color. Maybe we should. The same sequence of colors as we do for plots. Maybe we should. I don't know. For successive players. Roger, Mark.
I think they are good in the sense that they are contrasting, and it's kind of what you want.
Right, but is there some mapping of those to, like, in other words, if I'm plotting something, am I going to have some other plot that's going to have the same colors? Okay, let's keep going here. Let me just see some things here. So a tree game is like the multi-way graphs that I draw. Is that correct?
They're literally trees, and so they're not DAGs.
I see.
And the big difference is that you kind of can take turns, so there are many potential steps. A matrix game is simultaneous, so both do the thing at the same time, and then it's over with.
Don't forget that we've now got these nice symmetrical layout things.
Actually, that's a really good point. Yes, I mean, we have been. That's been an issue here. So, but I forgot that we actually have them now. So.
Yep. So these will look nice.
Yes.
Okay.
The end node there, do you see the leaf nodes?
Yes.
They are trying to represent the payoff vector. So
by the lightness or darkness of that color?
Right.
As opposed to, why aren't you doing that? Since in the other case, you're doing that by the height here.
Yeah,
right?
we probably should. Actually, that's a good point. I think we probably should. Yeah, because that's visually very much better. Geometry is always better. It's the strongest signal.
I think you should just make them into miniature bar charts, and they can be bigger because that's the final payoff.
Yeah,
they can be bigger.
No, it's a really good idea. Okay, that's obviously a better idea.
Okay. Also, the blue of these things seems questionable, given that you're using blue for this.
Yes, probably should also be gray.
Yeah, I think it should be gray. And now, so are these the main graphical things that we have?
Yes. But they are richer in the sense that if you go to tree game plot, you'll see that it has sort of multiple features, so a tree game can have, well, there's labeling things, obviously, but it also can have probabilities, like for a nature player with games of chance. These are prototypes. And it can have something called information sets, which is, you scroll down a little bit. Next.
Right. By the way, I don't think the call out wants to be there. I think you just want to, well.
No. This is kind of for, well, we can use it because it's there, but
yeah.
So
also,
information.
You need to set performance goal error quality, right, for these, so you don't have these gaps.
Yes.
What's an information set?
Okay, so information set means that you can't tell those two nodes apart. You don't know where you're at.
Yeah, I get it.
It's like, like a poker game. I don't know my opponent's, cards.
Also reminds me greatly of the merging for DAGs.
Yes.
Interesting. So if you were to give me a tic-tac-toe game tree, it would differ from my game graph by the fact that it has a bunch of quotes information sets, which I would choose to merge, correct?
I don't think tic-tac-toe has any information sets because you can see the game all the time.
Well, then explain something to me. Hold on one second.
But you could probably come to the same game state multiple times now that I think about it.
So look, here's what happens.
Yeah.
Okay.
So you have a DAG.
You have a.
But that is, okay, so what one tries to visualize with that game tree is each player's choice. And is that
I understand, which is not quite as obvious here. This is a question of the game states.
Yeah. Actually, kind of thinking that
I mean, it's similar, but but this is, as you see, a DAG.
Yes, obviously.
Yes, it's a fundamental different comprehension of game theory. The game theory uses trees for sequential games and then uses information sets to convey the idea of similar game states. But it would use multiple nodes for the same game state. Whereas if we see it in the sense of not game theory, but game computations and basically like the research on gaming and that kind of thing, they use DAGs instead of trees. So it's a different understanding and use a different structure.
Right. Game graphs, by the way, were invented by, as far as I can tell, by Zermelo in 1912.
Who?
Zermelo.
Oh, yeah. Yes. He came up with the idea that you could actually sort of compute the optimal thing from the end nodes.
I mean, he was an attacker of Boltzmann about second law, and then he did set theory, and then he has this bizarre paper in the Proceedings of the International Congress of Mathematicians of 1912, in which he introduces game graphs with some whole backstory about sets. For what it's worth. It's mildly interesting. It's fairly clean paper. But just to understand, I mean, it's sort of interesting to me because I didn't know about these information sets. And for me, the whole issue of turning it from a tree into a DAG is a story of kind of how observers equivalence things. So it's interesting that that idea already exists in game theory. I didn't know that. Okay, so let me just understand. So there's some graphics here to do, and then there's actual computations on games.
Right.
So just so I understand with that,
so those three functions there, and the next three are for matrix games, and the other three there for tree games. You can see they parallel each other completely.
Yeah, okay, I understand. So let's look at these for a moment, and then I want to come back to the visuals and the stuff if Jeremy is able to give us some input here. Okay, finds one optimal strategy profile for the matrix game. Okay, so what is this? How does this actually work? Okay, so there's Prisoner's Dilemma. Okay, so it's had an action labels option. Where the heck is a 1/5 coming in for chickens?
Well, I mean, it depends on the payoffs, I guess.
It depends on the chicken.
Chicken is a game where both drivers drive towards
I
each
know
other,
what the game is. I don't understand why there's a 1/5 in there.
Well, you can decide to do it randomly, and there is some payoff where if both players adopt the same strategy, then there's a natural equilibrium.
Okay, but I mean, the 5 is you chose the 5. There's nothing about chickens having 5 legs or something that causes there to be a 5 there. I mean, that's just
that's just the evaluation of the players. Yeah.
No, I understand that, but the definition of the game of chicken just says you both lose if the cars crash into each other, more or less.
Sure. Right? So we need to define a default value for that lose
No, I
situation.
understand. I was just confused by the 5 there because it is not obvious to me that the default value should be -5 as opposed to -10 or minus whatever else. See what I'm saying?
Yeah.
I just don't know if there's a standard for the 5, so be it. It seemed odd to me. Okay, so if I say here, to get that matrix game, how would I specify that matrix game? For each, this is where I need to understand what.
Yeah. Okay, so here you have, that would be that second one. You know, where you have to give a matrix of these payoff vectors for all the combinations of actions.
No, so let me ask a question. I had a design for this years ago, okay, in which the action names occurred as keys in an association. That surely needs to be supported here. Defect, cooperate, whatever else, right?
What's the design?
The design was, well, I mean, I have these designs. You want me to pull them up? I mean, they're from like 5 or 10 years ago.
Okay.
You did look at them, right?
No,
you did look at them, didn't you?
No, I don't know what you're talking about.
Oh, for God's freaking sake.
There is a association design for tree
look
games.
Look at this, game theory. Here we go. Game theory 2021, SW notes. What date is that? 2018. I assume you've looked at this. I hope you've looked at this. I sure hope you've looked at this. Don't tell me you haven't looked at this. I'm going to be really annoyed.
I don't recognize this.
Well, you clearly were involved because I didn't know anything about LQ.
Okay, so I was there, but I don't remember this. This was probably in some discussion meeting or something. So what's let's look at the input design that you have there.
Yeah, no, I understand, but let's also make sure you have all this material.
Okay, that would be great.
So who's here? Felipe, can you make sure?
I can make sure that happens. Yep.
Okay. Okay, so this is another thing you need to make sure of, is that we have these game specifications as, remember, you know that we have this, right? We have things like tic-tac-toe as a game. Eric Weisstein put a bunch of games in.
I did not know that.
Oh, come on, guys. What are these called? What is going on with what is going on? I've complained about this for several days. What is going on with this nonsense here? With this, the first time I do this, this is something, Felipe. Can you please track this down? Can you please report this? Look at the timestamp, send the video, right?
Yep. Right.
Between Roger, the other Roger, and Jeremy Michelson, whoever. Okay, so let's look at what that is. Oh, famous math game. Okay, who was to know that? Okay, so clearly some of these are relevant to you.
Yes.
Like rock, paper, scissors, and so on.
Dino's Dilemma also is covered by us. Chicken is.
I think they all covered.
More or less. We got 51 of them totally.
Okay, so please coordinate them with this so that they get into this this form.
Yes.
As well, and it's not completely obvious to me that you need something separate from the entity framework. In other words, that you need a game data thing. That's really not obvious to me.
This is a very different. I mean, it's fine. We thought about this. So should it really be entity? But I mean, it's just a choice we made. Yeah.
Well, I think this looks pretty good to me. I don't know why you. I mean, I assumed you would know that we already have these things.
Nope.
You got to do better at stuff like that. My God. Okay, let's take a look at the design here. This was I guess this is player 1 and 2 and so on, which could also be named players. Am I making sense?
Mm-hmm.
And these are what they're doing. And these are the payoffs for each player. Right?
Okay.
So that's presumably quite similar to what you have, but maybe a different format.
Yeah. I mean, we have that, that second association, the values there, or the vectors in that matrix.
Well, so you're assuming that the player names are 1, 2, 3. Is that correct?
No, you can give player labels if you want to.
No, but that's not. I mean, wouldn't it be better to use an association for those things? I think so, rather than having to have an option that just sort of hangs out and has to be kept compatible. I mean, we did think about this.
I mean, this is really hard to type in. This is horrible to type in. This is like,
it's not easy to type in. It's easy to
super
generate.
much duplication.
Right. It's easy to generate.
I think there's no problem of accepting it, but I just doesn't seem. Yeah.
Yeah, I'm pretty sure we'd consider association, and we thought that what we have, the matrix game, actually should be matrix specification, basically at some level.
Well, so let me understand what you would do in this case. You would simply say cooperate and defect. Our strategies are, moves 1 and 2. Is that correct?
Actions 1 and 2, yeah.
Actions 1 and 2. Okay. And then
I mean, you could give the actions labels too. They're action labels and player labels.
No, I know.
Both.
I saw that. I saw that.
Okay.
You might be right. Okay.
Yeah.
I just kind of liked this because I thought it was very explicit.
Well, we can very much eat it, but I just don't. And maybe for programmatic generation, I don't know, but it looks.
I don't know either. I don't know either. But anyway, okay. It seems not completely stupid. Okay, so let's just.
So that will become
Okay, so this
an
is
array of all that stuff for a 3-player game.
I think so, because this says array form of payoff tensor, right?
Mm-hmm.
Whereas in the matrix representation, you are unrolling, if I'm not mistaken.
What do you mean?
Well, let me look at
it takes an array. We just named it matrix because that's what people call it usually.
It takes a depth n array where n is the number of players. Is that correct?
Right, n+1.
n+1. Yeah.
Why is it n+1?
Because you have a payoff vector at the end point, at the deepest part. It's like color components.
Oh, I see. So you're describing the vector. The 1 is for the payoff vector.
Yeah.
Right. It's for the vector of payoffs. But if just treated the payoff vector as a
Yeah. And another interesting way to do this is actually sort of the other way around. You can have a vector of payoff arrays, and they are kind of be rank n or depth n, each one. Kind of like you do with colors. So you have interleaved colors, which are standard representation, and you can also have color components, which give you a red matrix, a green matrix, and a blue matrix.
I get it. I see. So in other words, I see. What you do is by action, you list for player 1, you list their payoffs by action.
Yep.
But it depends on player 2.
Yeah, so they're all matrices or arrays.
Okay.
So you need to know what all the other players do too for each case.
All right. Well, I'm not particularly pushing my format here. Okay, but I think you should at least look at it.
Sure.
Sure. Mark, we will look at it later.
Yeah.
Okay. All right. So look, since we have Jeremy here, let's I just want to have a quick look at what the functions are, and then I want to come back to the design.
Okay.
Okay. Find Nash equilibria, etc. So that's one of the things you can find here is.
So the idea eventually is to generalize it to, like let's say you only want pure strategies. They may not always exist. A Nash equilibria always exist, but that sort of forces it to be mixed. But when you start to do more advanced games like multiplayer games,
mixed is when there are non-zero probabilities there can be non-zero probabilities for multiple things. Is that correct?
So they're not necessarily 0 and 1 only.
Right. So pure is when it's like you just do this or you just do that.
Right.
And the other is you're picking it with certain probabilities.
Yes.
Okay.
And but when you start, particularly for multiplayer games, then we haven't gone into this now, so I'm just talking about kind of potential future. But you start to be more discerning about what kinds of equilibria you want. Yep. You may not want sort of a very unstable equilibria, like a knife's edge type equilibria.
Yeah, I get it.
Okay. But we can't discern them today.
But by the way, I just want to point out to you, I assume you've looked at all the demonstrations that people have made for game theory.
Yes, and we also use them in the examples, quoting them and saying that inspired by whatever. I mean, I don't know whether they'll actually use it in the final, but we have looked at all of them. Yes.
Okay, fine.
Mark, is that correct?
Yep.
Yeah. That is part of the example generation.
Verify matrix games.
So this is super. I mean, it might sound silly, but it's super useful. It's super cheap to verify that a strategy is in Nash or optimal compared to computing one. And one of the things that you can do, let's say that you, Stephen, have come up with another algorithm for guessing a strategy.
Yeah.
Is it going to be optimal?
How do you check optimality quickly?
Shit, I don't even remember now. I have to go to my notes, but it's super cheap to do.
It has to do with the properties of Nash equilibria, where every player doesn't have any advantage in changing its actions, basically.
So you can just do a perturbation analysis or something around this,
basically,
around the minimum?
Yeah.
So one of the things that's useful, like let's say that you want to just find all pure strategies, just enumerate them and check.
Yeah, I get it. I get it. Okay.
So what people optimize for and what Nash computes is the expected, the maximum expected.
Yep. But for a particular, you can ask for a particular strategy, or a particular set of moves.
Yeah. Exactly.
How should I think about the difference between, quote, strategy and a move? I mean, this is one thing that always confuses
Well, for matrix
me.
game, it's the same thing.
Yeah.
Because there is only one.
I hate
Well,
that.
it's just
I
one
hate
move.
it. I know.
Okay.
I mean, it's always so confusing to me because strategy, I think about iterated games where there really is a strategy based on history and so on.
Yes.
But that's right now, all of that is off the table for us, right? We're just
Yes.
dealing with one-shot games.
Yes, we did not do iterated games.
Even though the tree games look like they're multiple moves.
Yes.
Are they multiple moves or are they not? I mean, can you do tic-tac-toe?
Yeah.
With a tree game?
Yes. And you can model iterated games as a tree game. But I think that one wants something that's a little bit easier to specify and work with, and et cetera, et cetera.
But so in a tree game, what's the specification?
Magnified a little bit. So it's basically following the tree, more or less.
Oh yeah, you actually have the tree there.
Yes, we do. It's kind of a little clumsy, but we have it,
Well, it won't be clumsy if you have a picture of it. If the tree is formatted, it'll look rather beautiful then.
Yeah, that's not the issue. I mean, I'm just saying that
I don't understand why you just say player 1 here. Where's player 2?
Because they are in the actions, that's how tree works, right?
So
I mean, it's obvious more. If you look at the next step, the tree where you have a tree head instead of a list head.
Yeah.
Okay. So that's the node, right? And then it's the children.
Which are themselves trees.
Yes.
Until you get to the leaves.
Yes.
I don't think this is a good way to specify it. I mean, you've got to say tree here. And here you really got to say, rather than action 1.
But it does. It's just if you scroll down, we gradually unravel it. Okay.
Why do you think that the tree notation is not nice?
Scroll down. You have to. Where is it? Well, actually, go look at an example, but you have to use these associations all the time. It's just really long. What's an example, Mark? It's probably in the.
An example of tree, I think it's later down there. Should be.
What does 22 mean? 22 means tree branch. Tree location 22 has payoff point 2. Is that correct?
That is not correct. So the payoff. So every payoff is a list of values, right? So the 22 there is payoffs.
What's the point 2?
The point 2 is the probability.
So this is a strategy.
This one has a.
No, it's a tree. So trees can have probabilities.
What does that mean? I thought that these things, the matrix game or the tree game, were defining payoffs for certain moves. Is that not correct? They define something else
if they have probability, it's like nature player. It's like a player that does those actions with those probability. You can't pick it. You know what I'm saying?
Okay. But it still has payoffs.
Yes.
Okay. What's the 0.7 then?
That's the probability of A.
Oh, I see. Of A doing those things. But so here, you've got to explain this a bit more, I think, what these do. And maybe you should you are making the graphic here.
Yes.
But now instead of graph, I could have said tree game plot.
Absolutely.
Game, right?
Yes.
And you should do that. You should do that here. Well, I don't think I really understand this.
Yeah, it took me a while. So let's iterate a few times. Either we can go up in the notes where we sort of unpeel it a little bit layer by layer, or we could look at examples, whichever you want.
I'd like to look at the graphics since we have Jeremy here. Okay.
Okay.
You know, there is a certain nothing new under the sun character to this whole thing. I had no idea that these information sets existed because these are basically the same thing that kind of simultaneity sets or equivalent sets or whatever.
Yes, they are.
Now, I don't understand. Is this a complete graph here that's just equivalencing all of those nodes?
Yes, they're all part of the same information set.
Right. So that information set is always you're lassoing them together with a complete graph.
Yes.
Yeah.
Okay. I had no idea. When were information sets invented in game theory? I've never heard of them. Not that I'm an expert at all in game theory. But what
I actually don't know. Do you know, Mark?
I'm not sure, but I mean, I've seen very early papers that have it. It's not, I don't think it's a very new concept in the sense, but yeah.
I'd be curious if you find out where it's from. I'd be curious because okay. So let's go back to the Jeremy question, right? So let's explain what let's see, where were we here? We were looking over here.
Matrix game plot, yeah.
Right. Let's see with matrix game plot. Do you have more recent pictures in here?
Yes.
Okay, so Jeremy.
Yep.
Are you with us? Okay. So what is this representing? By the way, I have no clue what this one is representing.
So you can see the matrix there, the payoff matrix, and those two halves.
Oh yeah, I have seen these before. Yes.
Right. So this is, we didn't invent this. Okay, it is used in the literature. I've only seen it from matrix games. As I said, we generalized it to array games or multiplayer games, which has more stripes. Sorry,
a bigger one of these. So what's happening here?
They actually come out pretty. Yeah. So where do we have that, Mark? Where do we have?
Okay. So Jeremy, I want to just explain what's going on here. These are two players playing a game against each other.
Okay.
Each box represents like the game could be, well, the famous one is business dilemma, cooperate or defect. Okay. And that's cooperate, that's defect for that player. That's cooperate for this player, that's defect for this player.
Yeah.
For each of those possible cases, there is an outcome for each player. Okay. And so the outcome is represented by a number. And what's happening here is the darkness or lightness of the color is representing for each. So in other words, this picture is always a blue, yellow. Every square here is a blue level, yellow striped combo. Does that make sense?
It does, yeah.
So
but
here,
so top corner is darker than the bottom corner. That mean there's times when nobody wins or something?
I've had a multiplayer for 4 players game with split squares. It's in social games. If you want to go to the, so in applications.
Okay, Jeremy was asking a specific question here. Can we answer his question, please? What this means is,
if you look at the tooltip, okay, which is not optimal right now.
There's a -3 there.
Right. Okay. And if you look at the more yellow thing, like up in the right corner, that is 2.
Okay,
so it's a positive payoff, and down in the left corner it had a negative payoff.
No, so I thought, what's 0 doing there?
Yeah, no, that's the payoff. That's not.
Oh, sorry, 0 is the payoff. Sorry, my bad.
So
my
this
bad.
Is -3 there.
Right.
-1 there. So it gets more the more negative the payoff, the lighter the color, Jeremy.
Okay. Yep.
And it's presumably normalized. It's presumably very much like color function scaling type normalization here, which we perhaps should reuse that option for this. You see
And
what
we
I'm
do.
saying?
I think we do.
Okay, all right, fine. Well, Mark can perhaps confirm that.
Mark?
Yeah, I'm pretty sure, and we can modify it with an option.
No, but color function scaling is the option you should use, because that's the
Yes.
option that determines whether it's, I mean, you should have a color function as well in this case, I think.
Yeah.
Okay, now you're going to show me in matrix game plot here.
So just
applications.
Application social games, just open it up. So there you have an example for 4 players.
Okay. Now, are these equal area?
No.
Yes. No, sorry. They're equal.
What are they equal? I think they should be equal area, right? Why wouldn't they be equal area? I think they might be equal area.
They
It's
might
certainly
be.
not. What's that?
They might be. I don't know right now. We could check that.
Okay. So my first point about all of these is this should have a mesh of some kind. It will be much less obscure if it has some level of mesh. Am I making sense?
Sure.
Some kind of gray or something mesh, I think. Jeremy, you should speak up if
No, I agree. Some black with opacity or something. Yeah.
Fine. So okay, so let's look at this example. And the fact that these crash into the error edges is wrong, but that's already been fixed, right? But these are bar charts that show the same results, the same values. And I have no idea why the center line isn't at the center of every one of these boxes. It should be.
Agreed.
Yes, it is in the updated code.
Okay, fine. Now, I don't know whether you want to. I see. So in this case, it's in the place where it is because the negatives get much more negative than the positives get positive. So you'll have a bunch of gaps left in the case where that thing will be much less tall because you get what I'm saying? But I think it's the right thing to make the zero payoff be significant. Mark, Roger, do you agree or not?
Yeah.
Yes.
Okay, fine. Okay, so
But
that's now
you're saying that the two here are equivalent?
These pictures are equivalent, yes.
They show the same information.
Okay, because the one at the bottom looks fairly uniform, right? Very subtle differences, and the top's just very dramatic. So what's the difference?
Yeah, good point.
Well, it's not very good it's not very good info viz. It's
not. Yeah.
Okay. So because what we're trying to do here is in this case here, in that square there, that's that square there, right? This should be representing the fact that there is blue and there is red, but there isn't much of the yellow.
Okay, so that's the toned down versions aren't toned down enough, maybe.
Yes,
yeah, because they're pretty strong still.
Yep.
Yes, it should be really very toned down.
Mm-hmm.
But that would have to do with the game itself. If we had a payoff of minus 100, then the difference in color between 1 and 0 would be even less.
But you know what? You shouldn't use a linear scale.
No.
Right? We've had that issue before for many other things.
In which case, I mean, if you're going to read it at a glance, you're going to need kind of a legend for it.
There is a legend option for it.
I know. But that's kind of what you need to decode these things.
Right,
unless you're willing
to. I think we can do
to...
better. I think we just need a transfer function for the color based on, okay, so first thing is, assume your color function scaling is true, right? Then, assume color function scaling is true. So we're rescaling everything. So we've got minus 100 going up to 1, for example. Now, I don't know whether we want to make 0 be special in some way. In other words, okay, first point. In the case of the bar charts, it's really obvious whether it's a positive payoff or a negative payoff, right, everybody?
Yes.
Yeah.
In the case of the colors, it is not obvious.
No.
So one question is, could we make it obvious? Because, let me point out something. You already know which color this is by where it is. See what I'm saying? So in principle,
sort of. I mean, it's not that obvious. I mean,
pretty
it
obvious,
is
by the time
standard
you have
order, but
16 things in here.
yeah, but how do you know?
Well, okay, so I want to know, is there a way that we could, for example, we now have cross-hatching, right?
Yes.
I wonder whether there's a way of using two different textures for positive and negative values. How symmetrical do we think it should be in terms of the representation between positive and negative?
That's a design question. I mean, seems fine
no.
to
I
me,
mean,
but
it's a meaning question because it's a question of whether if the payoff is, so I mean, look, what degrees of freedom do we have? We can change the color, actually change the color, right? We could, I mean, what you were doing right now was you were changing presumably the lightness of the color. Is that correct?
yeah.
Okay, let's go through what we can change. We can change the size of the stripe, okay, which I think it is on the table to consider changing. We still need to indicate, I mean, so we could change the size of the stripe, which I don't think is crazy. And we could have the area of the stripe be the magnitude of the value. And for example, one thing we could do is the magnitude is the area of the stripe, and the sign is the lightness or not lightness of the stripe.
What's a not lightness?
Well, I mean, just the regular saturation here, as opposed to a lightened version. Right? In other words, that that there are two states for the color. It is either, which I think would be better than having many states, which I think is absolutely unreadable. So what I'm suggesting is,
oh, just note positive, negative.
Yeah, no, what I'm saying is this: the size of the stripe, the width of the stripe, determines the modulus, determines the absolute value.
I see what you're saying. Yeah.
Right. And I think that will be quite nice. And whether it's positive or negative is determined by whether it is, light or regular. Do you see what I'm saying?
It's worth trying.
Jeremy, you have any comments on that?
Well, I'm thinking if you change the size of the stripe, the width of the stripe, are we leaving gaps when they're all small?
Yes. I mean, it could be 0.
So they get thin. So the blue one, does it kind of go towards the bottom corner?
Wait a minute. I thought the payoffs always added up to 1. No, they don't.
No,
they don't.
No, they don't. They can be anything.
Yeah. Just wasn't sure how the filling would work. I'm picturing either, gaps, stripy gaps.
Well, I mean, what about just saying, I see. The problem is that you've got to be able to compare the values between different squares here. Right?
Yeah.
And what if they're all 0, for example, for one of these squares? Right? For one square, they're all minus 100. For another square, they're all plus 50. And for another square, they're all 0. Right?
Yeah.
So let me ask this question. Given that you've got to be able to compare that, I just don't think this color saturation is going to work. I think it's going to look terrible. Now, again, Jeremy, any thoughts about, okay, so one thing that's on the table here. So first of all, we've got to distinguish positive and negative somehow. Am I making sense? Do you agree, Roger, Mark?
I'm not sure how, I'm not sure how important that is, to be honest. Maybe it is.
I think it's important. I think it's critical. If it's a negative payoff in that place, what would happen if we stippled or crosshatched the color if it's negative?
I don't know. We could try.
In most game matrices, are the payoffs usually negative or usually positive, or how do they compare? I mean, a lot of things, like a lot of cases that I can think of, there are a lot of negative payoffs.
In zero sum, you'll have one positive, one negative. So I guess that's the obvious one where you will have opposites which you need to highlight.
Yeah. The most popular games are either all negative or a lot of classical examples are mixed. There's not a lot of games that are all positive. That's rare. But
Okay.
yeah.
All right. Okay. So what would be a good textural clue of negativity? Is it cross-hatching? Is it stippling? Is it something else?
Well, if we're zeroing down on zero, which is gray, the only thing I can think of is going to inverse colors.
Yes, which is possible. It might not look bad. Given that you know what it is referring to by the fact that it is, by its position. The only problem is that with these particular, we may have to change the choices of colors because otherwise we may end up with confusing, you know what I'm saying?
True, yeah.
Jeremy, do you have any thoughts on this?
I think it's going to get really confusing. Yeah, I think they're going to crash into each other immediately.
All right. Well, what do you think about the texture approach?
Maybe. I mean, so what is it at zero if we use texture?
It's basically gray.
Okay. So full color to gray and then gray to a stippled color. So
Yeah,
like a
that's what I'm
strong negative
suggesting.
would be kind of strong stippling of a
Yep.
color. That makes sense, I think.
Well, the stippling, I think it will be constant stippling for all negatives, but the amount of stipple. Well, no,
But there's
I
a
see what
range
you're
of
saying.
negatives, right? A scale of negative.
Yeah, right. But what you're perhaps suggesting is that we go on the gray and we stipple in the color as it goes more negative.
Mm-hmm.
So at negative high value, it's kind of, you got to still be able to see that it's stippled. It can't be fully filled, otherwise it'll look like positive value. Well, we should try this. Okay, so that's that part of it. The next part of it is the side stuff. Okay. So what you're doing here is you're unrolling. In general, this would be a
We're sort
rank
of
4 tensor.
flattening, right?
Yeah, we're doing level, we're doing flattening to an unrolled matrix, so to speak, where
flattening some to be row dimensions and some to be column dimensions.
Yeah. And I mean, down here, okay, I don't quite understand why is there 1 and 2, 3, 4? Why does it look like that?
That's we used to have that as an argument. So that says dimension 1 be row player, dimensions 2, 3, 4 be column players.
What's the difference between a row and a column player other than visual?
None. It's just for visual. It's just to be able to visualize in 2D.
By the way, I assume you're going to be able to eat tabulas here. We should be able to.
So you just convert them to arrays? Yeah, I think that.
Yeah, we can, but I'm just thinking of how natural it is or not. It's just not.
Yeah, okay. Well, anyway, but I mean, when game theory becomes really industrial, do you end up with games with huge numbers of players or not?
I don't know. I found that there's just very little work done on multiplayer. Maybe that's because it's been so hard to do.
But what about things like people do like the famous FCC auction, for example.
Yeah.
Was a practical example of game, and the Law of the Sea Treaty was another one.
But my guess is that they started them more asymptotically, right? So not
Well, my assumption, but like the law of the sea treaty, I would imagine that there's.
I don't know about that one, but it's.
Well, it was. I mean, it was years ago. That was like 30 years ago or something.
Okay.
More than that, even. That was a. I mean, look, somebody who'd worked on it told me it's a great application of game theory. Beyond that, I don't really know. Go ahead.
Maybe one limitation we have is that those games have finite number of actions. Usually auctions and things that bet on prices and that kind of thing have an infinite amount of options, which is not something we cover.
Okay. I'm just seeing a random example here. It's a random example. Oh dear. I think this is getting very political very quickly.
It looks like a tree game.
Yeah. It's actually kind of interesting the way that this. Oh dear. Then we end, and everything's in Chinese, and it's all about the South China Sea, and that's terrible. So who knows what's going on here? Oh no. Wow. Okay. Interesting. Okay. I do think this gets pretty. Look at this. Well, all sorts of countries with all kinds of issues, as every country has.
Yeah.
This seems to be an Iranian game theory and fisheries effort. Now, the real thing where you know there's something funky going on is where it's a country that is completely landlocked that's doing fisheries rights, or, anyway. It's quite interesting. I mean, it will be useful, I think, to survey some of these application areas.
Yeah, of course. So part of what I think that we provide here is that it's kind of like a solid sort of introduction to games, and this is like your course, like an economist, like economic students, business students, that kind of thing.
I want to know what these papers where people are actually doing this stuff, whether, whether, I mean, like here, okay. Okay, I mean, can the things we have actually do this? I bet they can. Really bet they can.
So I see coalition there. So that introduces another thing. What we do now is called uncooperative games.
Yep.
There's another direction, which is cooperative games, where you can form coalitions, where you sort of funnel some of the payoff to some of your friends in the coalition if they agree to certain things.
Right. Well, I think it'd be worthwhile. It's just worthwhile to understand because, this is a typical thing that we have. We have some, the bad case is when we have core functionality. The good case is when we have core functionality and you can readily build on it to do the fancy stuff. The bad case is we've got basic functionality and it's unbuildable on. So,
well, I think continuous games are quite dramatically different from discrete games.
Yes.
In terms of, I mean, it's kind of like our continuous mathematics from discrete mathematics. It's like quite different.
Sure. But okay, I still just want to know, I mean, iterated games is something I've thought about a bit. And that's right now completely off the table for all of this.
Yeah, I thought we could do it, and we could sort of, yeah, we have to do it another round, think through. But one of the things you can.
I did those design notes from before do have things about iterative games.
Mm-hmm.
But okay, we're just dealing with the graphics here. Okay. Mm-hmm. So we've got this case and we've got the tree case. And in this case, we're not able to represent probabilities because matrix games don't usually have probabilities, right?
No.
You're just saying what the things are. And tree games have more information because they also have the tree edges, which can have probabilities associated with them, right?
Yeah.
Yes.
Okay, let's just bring up that picture. Okay. So, Jeremy, we are trying to represent in here this square represents blue player made that choice, yellow player made that choice. Make sense?
Yep.
So in the tree case, it's blue player made that choice, yellow player made that choice, so to speak.
Okay.
And in principle, the outcomes here for the trees. Yeah, I mean, basically what we're looking at, I see. So I'm now understanding this a bit better. This leaf could be a micro bar chart, or it could be a micro stripe plot.
Yeah.
And we should have both of those options.
But why is it something else?
Here?
Yeah.
Well, it shouldn't be. It's wrong.
Okay. All right, fine.
Right. So it's either a miniature one of these or a miniature one of these.
Okay.
Okay. Now, meanwhile, the edges here are miniature versions of what's in this tree here. And in principle, these edges could have probabilities, but we're not choosing to do that.
Well, when you highlight a strategy, then they do have probabilities because that's what a strategy is. You know, like the green player picks left action with certain probability.
So how are we representing those probabilities? Presumably the same way that we do here, with the thickness of these tree edges.
Yeah, and or labels, both.
Okay, all right. So I'm now convinced that I was wrong previously, and that it is correct that these things should be represented like a tree. But what's been done here is that we have factored this tree into different layers, row layers and column layers.
Yeah, but it's different, Stephen, because even though we show super simple graphs there, they can go on for many layers to go. The blue could play again. So they're a little
play again.
Sorry?
In a non-iterated game?
Yeah, that's what these tree games do. You can have as many steps as you know.
Tree games or this one here?
No. These in the Matrix game, they're all simultaneous.
Yeah, no, right. For the tree game, I get it. You can keep going, and you can have a blue layer, you can have a yellow layer, you can have a green layer, etc. Is that correct?
Etc. But blue can get another shot later, kind of like tic-tac-toe.
I understand. I understand that. Yeah, I understand that. I think this is less controversial. The only question, so in this case, then, I'm kind of beginning to buy into your little mini trees here. Although when we highlight a strategy, what we're going to have to do is thicken up that edge and that edge, for example, right? Representing the probabilities for the green, the probability for the red.
Yes.
Right. But what can we do, Jeremy, for these, the superstructure here? Should it be gray? Should it be dotted? What should it be?
In which, just by default?
Yeah, by default.
Dotted feels like a choice, like a special case, right? Like if you're trying to highlight one and kind of diminish another, maybe it's dotted for the one that's less likely.
Well, maybe the dotted is what we do for zero probability.
Yeah.
But in general, maybe what we do, or no, maybe what we do is just like these are zero lines that should be gray, right? Here.
Right.
These can be gray. I just worry about having things where there's gray this bar and this bar is gray and so on.
Yeah, I mean, I think it makes sense. We could make the tree edges gray and then those like tree structure gray. That would fit. And
yeah, I know, but then we have this. We've got to have these things be gray as well. So we're going to have multiple grays here, and they shouldn't be the same gray. We've got 3 grays. We've got the gray of this boxing, we've got the gray of these attachments, and we've got the gray of this center line. Make sense? Jeremy?
Yeah, it does. Sure.
So, I mean, my feeling is this gray should be the darkest gray. This is the intermediate, and this is the lightest, I think.
Yeah, and we've got thickness to play with too.
Fair
I think
enough.
the grid can be nice and thin. It doesn't need to be that thick.
Right. Right. Fine. Okay. I think we got a plan here. Do we agree with our plan? And in this case here, we'll be thickening up these arrows, which, by the way, are probably gray arrows, right? Because otherwise they'll be confused with these colors.
Sure.
We are going to be changing for this version the default colors anyway. It's not totally obvious to me we should use the successive curve colors here. Anybody want to comment on that?
We could use what we use for like contour plots, which are I guess that's a continuous range.
Yeah, I mean,
but
That's the problem. I think you want contrast between.
Yeah, we do absolutely we do. Yeah. So
well, maybe these are okay, but they're going to be brightened up anyway for this version. So that is what it is. Okay. Anything else we need to figure out?
Just a note on this one. I think the thickness of your white kind of radius, it's just really heavy when you're covering up these lines.
It's wrong. Jeremy,
Yeah,
it's
okay,
wrong.
good.
It should have been a scrim.
Okay.
And right now it's a full background. This is not final and in any way, but
okay.
They're sort of prototypes. It should have been a scrim or a call out or something.
Mm-hmm.
This is nice stuff, guys. Okay, anything else I should look at with this game theory, and then we should probably wrap this meeting for today.
No.
All right, let me just look at the agenda for a second. Yeah, game theory data I really think probably should just turn into those entities, but take a look at that.
Sure. Yeah, let's take a look at that.
Okay, and then another time we got to look at Fourier and discrete calculus and so on.
Yeah, there's not much. Fourier is just some documentation plus numerical evaluation.
It's
and,
you know,
we should probably let Jeremy go, and then we can just talk
sure.
for another few minutes.
So,
okay. Bye, guys.
Bye.
You know, after Laplace transform, Fourier transform is the most important, and they're kind of almost equally important. So they've got spruced up. They've got some TLC, and one of the things that people want is this numerical evaluation business. So when we can't do symbolic, we can do numeric.
Which we're just going to do automatically when we can't.
Yes, well, we actually
you actually have to give a sort of a numeric entry.
Yeah,
I see. But so when we can't do it symbolically, we need a message or something that indicates that you might be able to do it numerically. Otherwise, I would just give up.
Well,
that's actually a good point, probably.
Yeah, we can consider that, I think, and yeah, fine. So even when there's an exact input and we can't do it symbolically, yes.
We might also consider that for integrals.
Yeah, so that's coming. I agree.
Okay.
And some convergence has just got the third argument, which was requested by the Wolfram Alpha people. So now this kind of
where are we looking here?
You can go to some convergence reference page if you want. So some convergence
new. Sorry.
Yeah, some convergence new. It takes the same arguments as sum. Okay, so you can actually look at that. Right. So you can actually see whether the actual sum converges. Do you know what I'm saying? And it matters over what you sum.
So n(1) versus n(0) will clearly be different, right?
Yes. Right. So it picks the singularity.
You sum to infinity.
It's the same syntax as sum, basically.
Same syntax as sum.
Well, what do we have before?
We
just
said
n, and we looked at asymptotically towards infinity. We didn't look at sort of finite. We didn't even have the technology to do it.
Okay, well, this is nice enough.
Yeah, this is requested by Michael and people like that, so we just did.
Okay, symbolic array variables.
The thing here is support in a variety of calculus functions, and this will continue to grow for several releases to come, we hope. And in a way, there is nothing new in this case that you're looking at there.
What would happen if we didn't declare it?
It would still work.
It would still pick up.
No, it would still work, because the main thing that this vector array symbols solve is the curse of listability.
Yeah,
so if you're not using any listable functions, you wouldn't have a problem.
Right.
And dot there's no problem there. So that case would work anyway.
But you learn for a few more, like as line integrate and desolve value and stuff like that. So it's just been extended to a few more calculus functions.
This is actually genuinely new here, because I think that line integrate and so on did not do the symbolic variables.
When we talk about this, we really have to talk about it as being, that we can do things more symbolically here. And then we have to say, sometimes you have to declare these things, because this really, it's very ugly that you have to do this.
Well, you don't need to, actually. It will figure out.
I know you don't.
If you use listable symbols in there in your integrand, you will have to use it, or you will get weird results.
Let's take a look here.
Oh.
Okay, so what's a good example? So if I say v plus 1, 2, it'll be garbage.
No, do v plus 1 or some weird, Yeah, that's a good case. Okay, look at that. What does that mean?
Yeah.
That's the curse of listability.
And I assume that controlled evaluation of the first argument of integrate shouldn't be there and shouldn't save 1.
Say what?
Controlled evaluation of the first argument.
Controlled evaluation.
How to do that?
Yeah.
What is that?
Well, I mean, you hold it and then you only evaluate it.
Oh, hold first type thing.
Oh, yeah. That's actually, some has got that. It causes any number of issues, because if you've got a random over there, what do we do?
So it does not be random. I mean, but the fact that that doesn't work is kind of, I mean, I understand why it doesn't work.
Yeah, if that worked, we would not need the new matrix symbols and vector similar stuff, right? I mean,
yes,
we still need it in all kinds of other places.
Yeah. I mean, we would absolutely need that, right? Because we need to know
but
properties.
Not in this case, yeah. So I'm just saying that in this case, because you have, I mean, I'm talking this use case, where you actually, it'd be great if we could do hold first or whatever, but it's not what we do, and because it doesn't make, you then don't get the power of the symbolics,
Okay, let me just keep going. I'm a little troubled by this. That wasn't from your definition up above. That's just on its own, right?
Right. That was just.
Well, X there looks like it's already.
Yeah, that's been a vector. That's a vector symbol.
Right. Yeah. Although that would have worked with just a normal X anyway, right?
Yes.
Yeah.
It's kind of a convenience that once you give vector symbol, then you don't need to give the second and third arguments. It figures out that for you.
I'm sorry, what? You don't give second?
Well, so normally DSOL would have 3 arguments, right? It would have the equations, comma, dependent, comma, independent. But in this case, we figure it all out for you and just give the answer because we know. We just
well, I mean, in other cases, look, I mean, if I type in, you know, dsolve y prime of x equals x.
Yes, it will work.
It just works there.
Of course,
that
yes.
worked.
That worked in 14.1 actually. That was the innovation over there. And
is that well documented? Because I didn't know.
Yes, it's right on top.
And we showed it to you. So you've just forgotten.
Yes. In fact, you can do. I mean, sorry, we can even do y prime equal to y. It should work, but that's okay. And that's just a curiosity. So for 80% of dsolve, we don't actually need the second and third arguments at all. They're gone now.
What about for solve?
Solve is a different creature. Adam can say, but you see with dsolve, we got a
I think
privileged.
solve also does it. Solve is trying to.
It does.
I mean, when it doesn't have parameters, it's easy enough to do.
Probably,
and dsolve is tagged by the fact that it's a function.
Yes, exactly.
And we have a clear notion of derivatives and all that, so we kind of know where to look. That's our solve. It's the same story over there. Nothing new.
It does bother me that we have to, I mean, I think in terms of presenting these things, I don't understand. If X is a vector symbol, why don't we just use, I'm just thinking in terms of the, in terms of displaying this stuff, I just don't do this. Just show this as integrative X vector, whatever it is. You know what I'm saying?
Yes. And that's what you do in let's say, for a talk or whatever. But
right, but I mean, if you and when you do this in the documentation, you could just say with.
Yes.
Well, I mean, the point is that X is a lot easier to type than, you know, constantly selecting.
I know,
and copy and pasting.
I know, but this is just going to cause so much trouble. People say X equals that, and if you say with, you know,
I see. Yeah.
XV equals vector symbol, whatever it is.
Yes.
And then you put it in to show how the typing works. That's fine.
I see. So it's local. Everything is local too.
Yeah, I just wouldn't put a thing like this that sprays garbage all over your session.
And so it's kind of go with
I think it's kind of bad, Stephen, because it's like whenever you want to demonstrate something, and the first thing you show is something that's irrelevant to your demonstration, like with or.
I know, but that way you just have the vector.
It's like right. So the basic examples use those directly, right? But I mean, right, it doesn't pollute your session, right? That's why documentation notebooks have their own local context, right? I mean, in a common workflow, you'll want to write X equals blah, and then, you know, use that X throughout the next 50 inputs.
Whatever.
Yeah.
Maybe at least you could not use X, use V or something. I don't know.
I see. Yeah. Yes.
Well, this was exactly why you did not approve basically this version of vector symbol when Jose and I showed it to you a decade ago, right? Or 12 years ago. You were like, I'm confused. Is string X the vector, or is the symbol X on the left-hand side the vector?
Yeah. You know, one of these days we have to finish all the things that I mean, I'm still waiting for subscripted pattern variables, which we worked on for version.
Oh, yeah, I remember that.
3, I think.
3.
And then we tried for 4.
We need to solve it one day. These problems are hard. Okay, anything else we should make sure to look at here?
No, I think this is done.
This is it.
Okay, great work, guys.
Thank you.
All right.
Thank you.
See you all soon.
See you.